Hello everyone, welcome to Math Made Simple. Here's another great episode we have lined up for you guys today. There's a very important topic when it comes to fractions that I deal with on a constant basis. I don't care whether it's elementary, middle, or high school. So many kids across the United States have trouble with fractions, and we're going to try to make it a little more clear. Today's topic, how to go from mixed number to an improper fraction. Yes, I said a mixed number to an improper fraction. So just as a quick recap, in case you guys don't remember the differences or your young learner is just now kind of beginning, trying to figure out what these terms are. A mixed number is kind of like the combination of a normal whole number and a fraction. It has both parts. So let's say you had 2 and then you saw another little tiny fraction next to it, and it's 2 and 1/2. That is called a mixed number because it has a whole number part plus it has a fraction, a partial component. Now we're going to talk about how to convert a mixed number to what's called an improper fraction, and it's called an improper fraction because it looks kind of funny. Improper fractions usually have a larger numerator than the denominator, and a lot of times if you look at fractions such as 1/2, you notice the numerator is usually smaller, right? 1 is smaller than 2, and that's typical standard form. But improper fractions, sometimes it's the other way around. And so we're going to talk about how to go from a situation like this where you have 2 and 1/2, and I'm going to hopefully be able to explain a little better why a number like 2 and 1/2 is the exact same thing as 5/2 as an improper fraction. So these two fractions, girls and boys, they are the same exact number. It's the same amount. This is like 2 whole pizzas plus another half a pizza. Well, that's the same thing as 5 slices of a pizza that's cut into halves, if that makes sense. So we'll get into that in a minute with some visuals. So just to give you a little teaser as to what it is that we're going to be getting into. So let's go ahead and get started with the first one. I want to go ahead and just bring on screen. This is an exercise I have some of my clients working on right now who are dipping their toe in this area of mixed numbers and improper fractions, and hopefully the visual, a lot I found, gives kids understanding, so then when they're doing the processes we teach, they have a little more grace, a little more motivation to do it. Okay, so if you look at this, you're going to see a great example as to really the same amount, but one's written in a mixed number form and the other's written as an improper fraction, right? The improper fraction, as I said earlier, has a larger numerator than it has a denominator. A mixed number has a whole number part and then it has a fraction. It's like a combination, right? That's why they call it a mixed number. So backing up, it's getting a little sloppy there with all the circles, so I don't want to confuse anybody. So let me just get rid of what I drew, and I just want to point this out. Let's look at this. Now this is a number line. A number line example can be a great tool where you can compare shapes against the number line, and that way you can kind of see the reasoning. First, I want to talk to you about the improper fraction, and then we're going to talk about the mixed number part. So the improper fraction is right here. Notice that you have two numbers. You have the 7 at the top, right? And then you have the 4 at the bottom. That's the denominator. The first thing you need to understand, folks, is that the denominator tells us how many pieces something's cut up into. Okay, I'll say it again. It tells us how many pieces something's cut up into. So if 4 is in the denominator, that tells me that, if you look even at the number line here to go from 0 to 1, notice they cut it up into 4 pieces. There's a piece right here. There's another piece right here. That's why they have those little hashes. That's 2. Here's another little piece right here. That's 3. And then so to get from 0 to 1, you can see how that line was cut up into 4 equal parts, right? And that's going to match the denominator here, the denominator being 4. It's cut up into 4 equal parts. So let's back that up a little bit so you can kind of see how it works. Now, if you look at the rectangular figure below, they're doing little squares to represent the hashes that you see right there on the number line, right? So if you look at this, there's going to be a 1/4 piece right here. Here's another one. You can kind of see how it takes 4 of these squares to kind of get from 0 to 1. So this is cut up, that rectangle is cut up into 1/4 pieces, right? Well, the numerator has to deal with how many of those 1/4 pieces you see. The numerator in this case is 7. So if I count each one of these little spaces, look at this. It should be 7 of those 1/4 pieces. Let's count 1, 2, 3, just make sure I'm not wrong about this, 4, 5, 6. You notice there are 7 squares, right? There are 7 1/4 pieces. You could almost say 7 times 1/4 if you wanted to, right? But I don't want to confuse you, give you too much at one time. Okay, let's back that up. So if you don't look at the rectangle, right? If you look at the number line, you see it's the same truth. Each one of those, from the first whole number to the next whole number, 0 to 1, it's been hashed up. It's been cut up into 4 pieces. But how many of those 1/4 pieces does it take to get to the point over here? Well, let's count. That should be 7 if we did it right. Let's count 1, 2, 3, 4, let's keep going, 5, 6, and 7. If you look at that line that's kind of vertically up in here, to get from that distance, we had 7 of those 1/4 pieces. So 7 over 4 is really what that's saying. That's how we write that amount as an improper fraction. But if you look above, we're going to now look at the mixed number component because it's really the same distance. It's the same amount. What they're doing, instead of counting up each individual little piece, they're actually going from the whole number and incorporating some of the pieces at the same time. For example, to go from 0 to 1, that's a whole distance. That's one whole number. Not a fraction, but a whole distance. But after that, we only have to go 1, 2, looks like 3 more 1/4 plus the 1 to get to this little boundary marker right here. So that's where they're getting the 1 and 3/4. It's one whole number plus 3/4 of another number. Notice it didn't make it all the way to 2. It's not going to make it to 2. It's simply 1 plus 3/4 more. And you can kind of see that on the number line. You can also see it with the rectangular figure, right? To go from here to here is one whole distance because you can see it on the number line. But there's also an additional 3 more squares that you have to encompass. So that's 3 1/4. We write that as 3 over 4, 3/4. Okay, it's 1 3/4 long. So that kind of gives you the why behind the what that we're doing, and this visual hopefully will help build a little bit more understanding when you see the process that helps kids go from mixed number to improper fraction. So this is kind of going the other way around. So if you look at the exercises, you see this is improper. See, it says 9 over 4. Well, notice this continues to be cut up into 4 little hashes before you get from 0 to 1, right? It's that same pattern throughout the number line. So that's why 4, again, is still the denominator. But notice, if you count up all these little pieces right here in the rectangle, you should see 9 squares, which is why the numerator is 9. Now the question is, if 9 over 4 is the improper fraction, what's the equivalent as a mixed number? Well, if you look at the number line here, you can kind of count. We can go a distance of 1 whole all the way out to 2 whole. So we know it's 2 whole numbers as far as distance, plus you have to go a fraction of the way past that, right? It doesn't go all the way to 3. It goes another 1/4 past the 2. So we're going to combine that and say 2 and 1/4, and that's really the exact same number as 9 over 4. These are the same amount. It's just different forms of writing it, okay? It's just different forms of writing it. Now that you see the visual, and feel free to pause this, explain it to your learner if you're a parent kind of watching this with them, or if you're a learner yourself, pause it if you need to slow down. But you have plenty of exercises that kind of do that. This one's cut up into thirds, right? So the denominator is 3, and you notice to go from 0 to 1, it's 1, 2, 3 little chunks that they've divided it into. So the denominator is always how many pieces something is cut up into. I cannot emphasize that enough. But if you go down here, we go a little bit further, you're going to see some examples as to how we can convert from mixed number to improper form without having to look or draw any figures. So if you look at number 1 right here, notice they have 2 and 3/4. If you walk through the process, you'll learn, or if you listen to me in class, you learn that to do that, simply you multiply the 2, which is the whole number part, times how many parts it's cut up into, which is 4. So 2 times the denominator, 2 times 4, that would give you 8, right? And then the last step is to add the numerator at the end. So once you get 2 times 4, it gives you 8. Then you add the original numerator, which in this case was 3. 8 plus 3 is 11. And you got to keep the denominator the same. So if you look at the original problem, the 4 was the denominator in the mixed number. As an improper fraction, it will still be 1/4 pieces, so we keep that the same, and you can see that throughout. So to look at a fresh one, we'll come a little bit lower here. Notice you got a whole number part, the 5, the denominator is 6. That needs to be multiplied. So you're going to be doing 5 times 6 to start this off. 5 times 6 is really 30, right? But not only that, you have to add the numerator once you multiply that out, 30 plus 1, so that makes that a total of 31. Once you get 31, that's your numerator, but the original denominator, since it was 6 right there, you got to keep it 6 when you give me the improper form. Oop, that circle looks horrible, folks. I can do better than that. 31 over 6 is what you get, right? So that pattern is pretty clear, and you can see this throughout, and that's the activity that you just want to do, you know, probably 10 to 15 of them. And there's something about hearing me, but there's something totally different about doing it yourself, where it almost becomes a part of you and your habits. You do it without even having to really put that much effort into it. Same thing here. 4 times 8 is 32. Then you would add the 3 to 32 for a total of 35. So I can already tell you that's 35. The original denominator was 8. 35 over 8. That's a real quick way of doing it. And you can see why that is, because the denominator, remember, is how many pieces something's cut up into. And so if you have a whole pizza that's cut up into 8 slices and you got 4 pizzas, 4 times 8 will tell you how many slices of pizza there are, plus 3 more pieces, right? All out of 8. It kind of makes sense when you look at it in light of the number line and in light of the picture that they give. So anyway, I'm keeping it short and sweet, but hopefully this light little touch is a refresher for those of y'all who are in our course program. But if you're just struggling converting or figuring out how to explain this to your young learner, this is kind of a tool that I think a gateway to kind of introduce that concept to them. Why is this weird looking fraction the same as this mixed number part? I don't understand. Those visuals can help. So anyway, that's all I got to say on this one. As always, like, subscribe, share, and click that notification bell, that is, if you want more teaching videos and you appreciate this content. Go ahead and smash that like button and click the notification bell. If you need tutoring services or you need some help or support for your child, we have one-on-one online tutoring available at our company, morrismodel.com. You can also do our 10-week courses that we have. Math Made Simple is about 5th grade and under, and then we have Algebra Made Simple for the high school grades. We have a financial course, Money Made Simple. They're very popular, and they seem to be giving people clarity, giving them a good foundation, filling in learning gaps, and giving them success for where they want to go. That's all I got to say on this one. I love you guys. I'll catch you on the next one. Peace.